So let's say you have to use the property of determinants to find the equation of the plane passing through not 2, but 3 points. Where do you even begin? Well, let's look at 3 points, and we identify them as elements. So this point will be x1, y1, and z1. This will be x2, y2, and z2. And this will be x3, y3, and z3. And because we are dealing with a plane passing 3 points, it's going to look like a shape of some sort. You can graph it out yourself, but in 3-dimensional planes, when it comes to applying the property of determinants, what does that look like exactly? Well, it's going to look like this equation. So this is what the determinant with all your elements should look like. Now what does it look like when you plug in your numbers? Go ahead and pause the video and do it yourself. In the meantime, I'll jump straight to it. So this is what your determinant looks like when you plug in your values. And from here we can expand by the first row. We can expand by cofactors in the first row. So it ends up looking like the following. Where you have x times determinant of 2, 2, negative 1, 1, minus y minus 1 times determinant of negative 1, 2, negative 2, 1, plus z times negative 1, 2, negative 2, negative 1. And from here we can solve accordingly. Don't forget to remember that this whole equation ends up equaling to 0. And let me make that fit on the screen for you guys. So I shouldn't have to ask what our next step should be, right? Right? Because all you have to do is take the determinant of this. So let me just clear up some space for you guys. Okay, so let's do some math. So in the first matrix, let's see here. 2 minus negative 2, that's 4. So that's 4x. Okay. Let's see here. We'll leave this term, and we'll do the second matrix. Negative 1 minus negative 4. Negative 1 minus negative 4, that ends up being 3. Plus 1 minus negative 4, that ends up being 5. And we can simplify this even further by distributing the negative sign and 3. And then we'll combine all like terms, move to the other side. So that ends up looking like this. 4x minus 3y plus 5z is equal to negative 3. Right on. Now, that's pretty much how you find the equation of the plane passing through 3 points. And we've done that by first identifying our elements. Let me just grab everything we learned and compile them. Wow, this is a lot trickier than I remembered. Okay. So we grab these elements right here, and we identify them as variables in their subscripts, and we use this equation right here in yellow. We use this equation in yellow right here since this is a 3D plane, and with 3D planes comes their line segments, and this is the expression you need to get those line segments. And from there, it's simply a matter of expanding by cofactors. And there you have it. You're now able to find an equation of plane passing through 3 points. If you like this video, please feel free to like, comment, subscribe, And if you have criticisms, please drop in the comments for me to review. Thank you.